Okay, good day doctor. So I am Min. So now I will be presenting the coding for our project. Okay, firstly for our project we have to include the required library, Liquid Crystal Software Serial DHT. Liquid Crystal is for the LCD, Software Serial is for the serial communication between the Uno and the LCD. And then also we have DHT. This is the external library we have to install separately. Okay, so that the DHT sensor can be used. Okay, so after that we have do initialization of the sensor. Firstly, we define pin 2 is the DHT pin, and we also define DHT type to DHT11. Okay, then after that we set the object name as DHT. Okay, before that we use three sensors, okay, namely the DHT11 sensor, that is also known as the humidity sensor, and PPD42 sensor, which is also the dust sensor, and also MQ135 sensor, which is also the air quality sensor. And for the actuator, the output of the sensor we use are different types of motor, mainly are servo motors, okay, to execute our task. Okay, and then we go to the second initialization of gas sensor, that is the MQ135. Okay, so we set the A1 connection of the sensor to Arduino Uno, and then we put it at a value, AQ sensor, air quality sensor, and then we set a threshold of 250 for the sensor. After that, the second initialization is the dust sensor. Okay, so dust sense connect to pin 3 of the Arduino Uno. So this is some variable, duration, start time, okay, sample time of millisecond 2000, and then low pulse occupancy 0, float ratio 0, and concentration 0 is because everything is not yet started. Okay, so we define it as 0. Okay, output actuator pins. These are the pins for our output of our motor, namely the sprayer pin at 4. Sprayer pin is for the motor to activate the water pump, and then the linear actuator pin 13, okay, is for the opening and closing of the window. Then here is the buzzer pin to sound, and then the vacuum pin at 9, okay, and the red light pin at 10. Okay, after that, initialization of LCD. Okay, so this is the pin connector to Arduino Uno. Okay, for the setup of our project, first we have to set up LCD begin 24, then the serial begin 9600 to connect to the correct communication number between Uno and the LCD, and then we set some delay of 100. After that, we set start time is equal to milliseconds. Okay, you also use for dust sensor formula as well. After that, some input setup of the sensor. We set the dust sensor that is previously connected to the sensor at Arduino Uno as input, and also the air quality sensor as input. Okay, then DHT sensor begin. Okay, for the output, so these are the actuators of the motor. So we connect it to the output. These two are motor. This is LED pin. This is the speaker buzzer pin. Okay, and the vacuum. Vacuum is a motor pin as well. Okay. After that, we digital write the output as low. The sprayer pin and the motor, these two motor as low first. Okay. Then this is some initialization of LCD. First row in air quality system. Second row is this symbol, and the third row is welcome, delay, and some clear. Then the looping. Okay, mainly the looping and the whole process of the sensor is over here. Okay. We will look through gas sensor, temperature sensor, and dust sensor. So for the function of the gas sensor, this is a function, and this function of the gas sensor. Okay, this is the gas sensor. So the coding is as such. So ppm is a variable. We set it connected to the analog sensor to detect the reading from Arduino Uno and the environment. After that, we print it out to our LCD, air quality, the value of ppm. Okay, this is a cursor, air quality, and the value of ppm. Okay, so this is the condition. If the ppm value, that is the gas sensor, the gas around the surrounding is more than the threshold that we set earlier, 250, then we will do something. The LCD will display the reading out. It's either gas level high or gas level good. Okay, then the LED pin will light up if the condition is serious, the concentration is high, and the actuator of the pin will also be activated, okay, to open the window, okay, to release the gases indoor. Okay, vice versa. Okay, so you can see LED pin is low, the actuator will turn off. Okay, the second sensor that I like to say is the gas sensor. The temperature sensor. So the temperature sensor, how it works is basically we have to put some delay. After that, we set some variable for the humidity and temperature. This is the DHT reading that we set earlier above. So it will get the reading and impose over this variable. Okay, so this is the display of the readings. Okay, into LCD over here. Okay, after that, this is a display to the serial monitor. Okay, it will display to the serial monitor of the PC, as well as over this code are displaying the coding and the reading to the LCD display. Okay, So first row is H, second row humidity, third row is T, temperature, and C. Okay, so the function is very straightforward. The DHT sensor will detect the humidity and the temperature. If it is more than 22 or 60, the sprayer pin, the actuator, the motor will be turned off. And then if it is higher, if it is still higher, we also will turn on the linear actuator pin. Okay, if it is less than 30, so the sprayer pin will be turned on and the linear actuator pin will be turned low. Okay, that means the motor is turned off. For this motor will be turned off, the window will be closed, but the water sprayer motor will be turned on to make the surrounding cooler. Yeah, or else the window will be closed as well. Okay, go to the dust sensor. The dust sensor. For the dust sensor, so this is the formula. Okay, so house in dust sense. So this is to detect the surrounding of the dust concentration. When we save it over here, the duration. So then log of efficiency, we set it as 0 previously. So it will add on with the duration. Okay, so to calculate it. So if the millisecond minus the start time is greater than the sample time, which is 30 seconds, then we will proceed for the formula calculation using this official formula, ratio equal efficiency divided by sample time times 10, and the concentration is as shown. Okay, this is the formula to calculate the gas and dust concentration in the air. After that, we will display the value, same as other sensors, display the serial monitor and also the LCD. After that, we will reset it to 0 value. Okay, so for the function of the sensor, if the concentration is higher than 1000, a lot of dust in the air, the vacuum pin of the motor will be turned on to vacuum the air, and it will delay 100 seconds. After that, it will work for 100 seconds. Okay, 1000 seconds. Okay, then the digital write of vacuum pin turn off if it's less than 1000, and then we will put some duration for the turning off of the motor as well. Okay, that's all from me. Thank you.
I will show a demo of the simulation and results. We used Proteus to do our simulation because they have an existing libraries for most of the sensors and components we need for our projects. To start the simulation, we compile our Arduino code into a hex file that is readable by the microcontroller. To compile, we click on verify, and then this will start the compilation, and the output file is stored in this path with the .hex extension. The .hex extension means that this is a hexadecimal file that is used to program the microcontroller. So to load this hexadecimal file to our Arduino, we edit the properties of the Arduino, and then in the program file we put our hex file here in the path. So now the simulation can be started, and in the first case we have the temperature sensor. So for example, the temperature sensor for the relative humidity, it can be, for example, let's set as high. So for example, 62%. And for the temperature, for example, we set at 50 degrees Celsius. So the results will be shown in the LCD display, which is the humidity is 62% and the temperature is 50 degrees Celsius. And for the output, we can see because the humidity is high, we see that the window control is turned on as shown by the relay, which is connecting the current to the motor, and the water sprayer is turned off because the humidity is high and we need to lower the water concentration in the room. And when we set the temperature to maybe lower, 42 degrees Celsius, and the relative humidity to a much lower value, for example 28%, the results will be recorded in the LCD display. 28% for the humidity and 42 degrees Celsius for the temperature, which will result in this output. The water sprayer will be turned on as shown by the relay, which is connecting the current to the motor. And for the window control, the window should be closed to concentrate the water inside the room to increase the humidity, so the motor is closed. So this is for the first case, the temperature and humidity. The second case is for the dust sensor. When we have a high value for the dust sensor, for example 3,300 particles per liter, the result will be 1,039 particles per tenth of cubic feet, and which is higher than the threshold we have. This value is converted to the SI unit, which is PSC to per cubic tenth of cubic feet, which is resulting in the output that the vacuum cleaner is turned on as shown by the relay, which is connecting the circuit, and the motor is rotating to suck out the dusty air from the room. And if the humidity or if the dust sensor is low, for example 900, the result will be 459 particles per 10th of cubic feet, which is lower than our threshold. So the vacuum cleaner is set to low or off, so that this indicates that the dust air inside the room is at within a reasonable level. And the third case we have is related to the gas sensor. So when the gas sensor is high, this is indicated by the variable resistor. The gas sensor is controlled by the variable resistor in the simulation. So we show that it's high. For example, 17% of the resistor is a high amount of gas, which will be shown in the LCD display as 852 after the conversion, which is a high amount of gas, and this will be indicated by the buzzer and the LED. The buzzer is on to indicate that the room is having a dangerous amount of gas, and the LED is turned on to indicate the same thing. And the window control is turned on to open the window in the room to let out the gas, to let the gas go out from the room. So that's all for the simulation for the indoor air quality monitoring system. And this is also the discussion of the results. Thank you.
So from the simulation result that we have done it before, we found out that there is two improvements that we can do for this project, which is the indoor air quality system. For the first improvement for this project is regarding the hardware. So for the hardware, we can use the low pass filter for the gas sensor. And second is the software. So regarding the software, we can reduce the use of global variables in our coding. So let's see in detail for the improvement for the hardware and software. Regarding the hardware, we use a low pass filter to filter out the noise from the sensor readings. So how we do it is we actually connect the one inductor and one capacitor in series to the output pin of the sensors. So by doing so, the system can filter out the noise from the sensor reading and thus improve the accuracy of the data. Yeah, so this makes the sensor can read accurately. And second, for the software, which we can optimize the code by reducing the use of global variables and also the unnecessary calculations. By using the global variables, the system can access the variables from anywhere in the code, which can make the code more difficult to understand and maintain the flow of the code. And also by reducing the unnecessary calculations, the system can save the processing power. So instead of using the global variables, we try to make the code we try to use the variables locally. So we try to pull all the global variables into local variables. So this is the two improvement that we can we have done for the simulation that can improve the system. So this is the third improvement, which is the last improvement of air quality system. So as compared to the existing product, we found that the existing product are mostly applied for monitoring instead of controlling. So based on the literature review as shown in the table below, we found that the embedded system that someone designed are mostly applied for monitoring instead of controlling. So as compared to our project, we are able to use the sensors, the input sensors, to control the output actuators by using the microcontroller. So that is the improvement as compared to the project or the existing product someone do. So that's all. This is the three improvement that we propose for improvement of the product and also the system that we have done. So that's all for our presentation. Thank you.